This is lesson 3-8, and we're going to talk about the slopes of parallel and perpendicular lines. We've already defined parallel and perpendicular lines, and you'll see that each of them has slopes which are unique to them. Parallel lines have the same slope, and if you think about that, that makes sense, because parallel lines are two lines in the same plane that will never intersect, and the slope is how steep it is. So if two lines are parallel, like if you want to look at this picture down here, these two lines are parallel to each other, or we're going to see if they're parallel to each other or not. But they're not going to intersect. They have to have the same slope. They have to have the same steepness. If they don't have the same slope, if one of them's a little bit steeper than the others, then they eventually will intersect. Okay, so parallel lines have the same slope. And we'll use that when we're writing our equations as well, this information. If two non-vertical, okay, so a vertical line, remember, is going up and down. If two non-vertical lines are parallel, then their slopes are equal. Remember, vertical lines, we learned their slopes, they don't have a slope. Their slopes are undefined. So we're talking about two non-vertical lines are parallel, then their slopes are equal. The opposite is true. If the slopes of two distinct non-vertical lines are equal, so if the slopes are equal, then the lines are parallel. So if the lines are parallel, the slopes are equal. If the slopes are equal, then the lines are parallel. And any two vertical lines or horizontal lines definitely are going to be parallel to each other. So that's parallel lines. Now let's look at the example right here and let's see if line 1, L1 and L2 are going to be parallel to each other or not, and we need to explain why. So in order to find out if they're parallel, we have to look at their slopes. Now they look parallel here, but let's actually check their slopes. So we want to find the slope of each line. Remember what we learned yesterday, the slope is the change in y over the change in x. So we'll start with line 1, and we're going to do the change in y over the change in x. So 5 minus negative 4, negative 1 minus 2, and we're going to simplify that. And then we're going to look at line 2, and we're going to do the change in y, 3 minus negative 4, over negative 3 minus negative 1, and we're going to simplify that. Okay, so the slope of line 1, just what I said, 5 minus negative 4 over negative 1 minus 2. Now a minus negative becomes a plus positive, so that's a 9. And then these are negative 1 minus 2 is negative 3, and I can simplify that to negative 3. I don't have to simplify slope, but it makes it easier to compare them at the end to see if they're parallel or not if they are simplified. And line 2 we said, line 2 is over here, sorry. Line 2, okay, is 3 minus negative 4 and negative 3 minus negative 1, and that comes out to be 7 over negative 2. So right away we can see that those slopes are not the same. That won't simplify, that doesn't go in evenly. So since the slopes are not equal, the lines are not parallel. Okay, they look like they're parallel, but one of them is a little bit steeper than the other. The slopes are not equal, so the lines are not parallel. Let's try another example. Let's write the equation of a line parallel to the line y equals negative 3x minus 5 that contains the point negative 1, 8. Now remember, to write an equation of a line, we either needed a slope and a y-intercept or a slope and a point. In this case, we have a point. We have the point negative 1, 8. We don't have the slope, but we have information that can give us the slope. The equation of the line I want to write is parallel to this line, and parallel lines have the same slope. So I'm going to use the slope from this equation when I write my equation of a line that contains this point negative 1, 8. Okay, so I'm going to start, I'm going to have a slope and a point, so I'm going to start by using my point slope form. Y minus y1 equals m parentheses x minus x1. Now again, this is my point, so this is my x1, this is my y1. And it's parallel to this line, so parallel lines have the same slope, so I'm going to use the slope of negative 3. If this didn't have y by itself, I need to get y by itself. You can't identify the slope unless it's in the form y equals mx plus b. Okay, so now I know the slope is negative 3, so I'm going to plug that in. Y minus 8, because the y1 is 8, equals the slope, which is negative 3, because it's parallel to that equation, x minus negative 1, and then I just simplify that. A minus negative becomes a plus 1, and I'm done. If I needed to get y by itself, I would distribute the negative 3 and add 8 to bring it over to the other side, but I don't need to do that if it's not necessary. The only time you might have to do that is if it was a multiple choice and all the answers had y by themselves, if they were in a different form. Now, perpendicular lines have slopes which are negative reciprocals. If two non-vertical lines are perpendicular, then the product of their slopes is -1. So perpendicular lines have slopes which are negative reciprocals, and we'll take a look at that tomorrow. Okay, and we'll practice some problems.